All right, so we're going to do example one for finding arc length with parametric equations. So one of the first things to notice is that it's very common on an AP to either ask you to set up but not integrate the integral to find arc length, which is what I'm going to ask for in this problem, or they'll ask you to set up and integrate, but it will be on a calculator section where you can make the calculator do the actual integration for you. That's not to say that there aren't arc length parametric questions that you have to do by hand. It is to say that they have to be very carefully constructed to make them manageable by hand. So they are in the significant minority of problems that you'll be asked to do. It's possible, but less likely. So for right now, we're going to focus solely on setting up but not integrating so that we know how to do that. All right, and again, read those instructions carefully on an AP. They frequently ask set up but do not integrate, or they will ask you to do the whole problem, but it will be on a calculator section, which would be free response number 1 or 2 on your AP exam. All right, so that said, this problem asks us to set up but not integrate the arc length integral for x of t equals 2t minus t squared, and y of t equals 2t to the 3 halves on the window from t is 1 to t is 2. So we know that the arc length formula, that my s is going to be the integral from t is 1 to t is 2, right? And it's the square root of, now in the last video I used dx dt quantity squared. You can use dx over dt quantity squared plus dy over dt quantity squared, all with respect to t. The other way to write this, if you like the notation better, is instead of using dx dt, you could use x prime of t. So inside that square root, it's x prime of t quantity squared plus a y prime of t quantity squared, all with respect to t. Doesn't matter to me which of those you pick. Remember, if all we're doing is setting up the integral, our job is just to find the equations for x prime of t and y prime of t. So since my x of t is 2t minus t squared, my x prime of t should be a 2 minus a 2t. There's no reason to simplify that. There's no reason to make it nicer. And my y of t is a 2t to the 3 halves. So my y prime of t should be, when I take the 3 halves, I'll drop it down in front and get 3 halves times 2, which is a 3. So 3t to the 1 half, because I lower the power by 1, right? So I now have my x prime of t and my y prime of t. So my integral should be the integral from 1 to 2 of the square root of my x prime of t quantity squared, which if I were you, I would leave as a 2 minus 2t quantity squared, plus my y prime of t, which is a 3t to the 1 half quantity squared with respect to t. There's nothing wrong with that answer, right? If you want to clean it up, you can. Certainly, if it were a multiple choice question, you might have to clean it up to find the matching answer. But aside from cleaning things up to find a matching answer, there's not a huge incentive to risk cleaning things up. So if you chose to clean this up, what you would probably do is you would probably FOIL out this 2 minus 2t, sorry. So 2 minus 2t quantity times 2 minus 2t, and you would probably FOIL, right? And similarly, you would probably take this 3 times the t to the 1 half quantity squared, and you'd square both the 3, which would be a 9, and the t to the 1 half, which would just come out as a t. So if you chose to FOIL this out, what you would probably end up with is s equals the integral from 1 to 2 of the square root of. When you FOIL this, you get a 4, right? So 4. Outer and inner are both a minus 4t, so that's a minus 8t, right? Last would be a plus 4t squared, and then this was all plus a 9t with respect to t. Again, if you were asked to simplify, your arc length s would be the integral from 1 to 2 of the square root of 4t squared plus a t plus a 4 with respect to t. That's a perfectly acceptable answer, and if it were multiple choice, it might show up as an answer. If it's not multiple choice, I can't see a logical reason why you would opt to do that, and I would stick with this nice, easily done answer that did not require simplifying or making simple math errors.